we are looking at -2, -1, 0, 1, and 2, because the domains are real numbers. This is e to the -2, e to the -1, e to the 0, well, that's easy enough, that's 1. E to the 1 we know is approximately 2.7, that's the best we can do. And then e to the 2, and now we need to do some calculations. So, e to the -2, and that is approximately 0.1. That's good enough. And then e to the -1, 0.4, good enough. Remember, my pen point's bigger than a tenth, so doing an approximation, good enough. And then e to the 2, 7.4. Now, do we already know what he's going to look like? Yeah, he looks like everybody else. So, -2.1, -1.4, just guesstimate, because 0.4 is about a half. 0 is 1. And 1 is 2.7. And 2 is off my graph paper. So there's your picture. And then we know he continues to go out and then continues to ride along the x-axis. Does not cross it. Does not. It looks like he touches it, but he doesn't really. It's like this thing, something coming down looks like it's going to just glide along the floor forever. Here's a word problem. He says an exponential function of the form f of x equals 76.3 times 5.012 to the x models the population of some stupid country in millions. And x, now this is important. Y has units, millions, and x is the number of years after 1996. That means 1996 is x equals 0. Because it's the number of years after 1996. So 1996 is 0. Yeah. And it says, without using a calculator, find the population in 1996. That's x equals 0. That's easy enough. So I want f of 0 is 76.3, 5.012 to the 0. That's what I mean without a calculator. 76.3. What's 5.012 to the 0? 1. Is 76.3 what? Million. To the nearest million, year 2000. 2000 is x equal 4. So now I want f of 4, which is 76.3, 5.012 to the 4th. So 76.3 times 5.012 to the 4th. You could put parentheses or not. And that is going to be what? 48147 million. To the nearest million. Oops. Wrong button.